Unit 3, The Air Around Us. Chapter 5, Earth's Atmosphere. Getting started. Listening for background noise. Page 87. Listen. Where is the person in picture A? Listen. Where is the person in picture B? Listen. Where is the person in picture C? Listen. Where is the person in picture D? Listening for background noise. Page 87. Listen. Why is the person in each picture having problems? Picture A.
It's so hot here. And humid, too. I'm going to need to take a shower because I'm sweating so much.
Picture B.
I should have stayed at home today. There is so much pollen in the air, and my allergies are so bad. I can't stop sneezing.
Picture C.
Oh, it's difficult to breathe up here. The air is so thin. I can't get enough oxygen into my lungs.
Picture D.
Oh boy, the traffic's bad today. Ugh, the air feels really dirty. Oh, I hope I don't get sick.
Interview 1. Pollutants in the air. Listening for specific information. Page 90.
Jeff, you work for an environmental organization, is that right?
Yes, that's right. I'm the director of an organization that tries to protect our natural environment in many different ways.
And one of the ways your group helps the environment is by protecting air quality?
Right. We're always thinking about air quality and its effects on people and nature.
What are some factors that affect air quality?
Well, there are a number of factors that affect air quality. First, there are a lot of pollutants in the air.
Interview 1. Pollutants in the air. Listening for specific information. Page 90.
Jeff, you work for an environmental organization, is that right?
Yes, that's right. I'm the director of an organization that tries to protect our natural environment in many different ways.
And one of the ways your group helps the environment is by protecting air quality?
Right. We're always thinking about air quality and its effects on people and nature.
What are some factors that affect air quality?
Well, there are a number of factors that affect air quality. First, there are a lot of pollutants in the air, and many of these pollutants come from human activities, meaning things that people are doing or making.
Can you give some examples of pollutants made by humans?
Well, the most common human-made pollutants that you see come from burning fuels. For example, when factories burn oil, natural gas, or coal, this creates pollutants that go into the air.
And cars, right? I think that's the example that most people think of.
Cars create a number of pollutants in the air. Have you ever heard of particulate matter? Particulate matter is tiny pieces of matter that are small enough to float in the air. Cars make a lot of particulate matter.
Can you see particulate matter in the air?
Well, you can when there's enough of it. In fact, if you look at a factory, sometimes you can see a dark cloud coming out of it.
Oh, I know what you mean. That big cloud of smoke that comes out of the top of the building.
That's the particulate matter. Some of it falls on the ground. You know, if you're in an area with many factories, you might see a black or gray coating on cars or on the ground. That's the particulate matter.
That's terrible.
But some particulate matter is so small, very small particles, you can't see it at all.
So people don't notice when they breathe it in?
Usually not. But even though we can't feel it, it can cause damage to our lungs.
We've talked a lot about particulate matter that is made by humans. Are there any natural sources of particulate matter?
Natural sources, well, one is wildfire that starts naturally from lightning or something like that. When a wildfire burns, it sends a lot of particulate matter into the air. Similarly, a windstorm, like in the desert, blows pieces of soil into the air. So, wildfire, windstorms, these are a couple of examples of natural sources.
Interview 2. Air quality. Listening for specific information. Page 91.
Shari, you live in a big city. Tell me about the air quality there.
Well, it can be bad, especially in the summertime. There are mountains near my home, but you can't even see the mountains at certain times of the year because the air is so bad.
By bad, you mean polluted? Dirty?
Dirty and polluted.
What does it actually look like when the air quality is bad?
It looks hazy. It's like fog, but it's brown like smoke, and that's why they call it smog. Smog comes from the word smoke and fog mixed together. You get smog. So anyway, the air just looks hazy, but it's brown.
When the air quality is bad, does it affect you physically?
Sure. When there is a lot of smog, I get really bad headaches. Sometimes my headaches are so bad I can hardly think, and it is difficult to breathe.
That sounds dangerous.
During the weather report, they always include a smog level advisory. It's basically a system to tell people if the air quality is good or bad. I think it's between 0 and 5, where 5 is dangerous and 0 is completely clear. Anytime it's over 3 or 4, they warn people to be careful.
So this advisory tells you how much smog is in the air.
Right, the amount of pollution. When I was in school, whenever the advisory was above 3 or 4, when we went to PE, we weren't allowed to exercise outside.
It's not safe to be outside?
When it reaches a certain level, the city decides that it's dangerous to exercise outdoors, so they tell people to stay indoors at these times.
Listening for specific information. Page 91.
It looks hazy. It's like fog, but it's brown like smoke, and that's why they call it smog. Smog comes from the word smoke and fog mixed together. You get smog. So anyway, the air just looks hazy, but it's brown.
When the air quality is bad, does it affect you physically?
Sure. When there is a lot of smog, I get really bad headaches. Sometimes my headaches are so bad I can hardly think, and it is difficult to breathe.
That sounds dangerous.
During the weather report, they always include a smog level advisory. It's basically a system to tell people if the air quality is good or bad. I think it's between 0 and 5, where 5 is dangerous and 0 is completely clear. Anytime it's over 3 or 4, they warn people to be careful.
So this advisory tells you how much smog is in the air.
Right, the amount of pollution. When I was in school, whenever the advisory was above 3 or 4, when we went to PE, we weren't allowed to exercise outside.
It's not safe to be outside?
When it reaches a certain level, the city decides that it's dangerous to exercise outdoors, so they tell people to stay indoors at these times.
Interview 3. Humid and dry air. Answering multiple choice questions. Page 93.
Kelly and Michael, thank you for talking to us about air today. Kelly, you live in a humid environment, and Michael, you lived in a very dry environment.
Yep.
Yes, I did.
Kelly, I know that you're a very athletic person. What sports do you like?
Well, I like hiking, running, volleyball. I also like basketball, and I especially love cycling.
Could you tell me how the air affects you as an athlete?
I think the most important factor for athletes is humidity.
The amount of water in the air?
Exactly. So if it's humid, if there's more water in the air, it can be very uncomfortable for athletes.
Why is that?
Because when you're playing sports, your body makes a lot of heat. You need to get rid of some of that heat by sweating.
I see. Sweating is important because it takes the heat out of our bodies. But how is that related to humidity?
Well, if it's humid, there's already a lot of water in the air, so the sweat stays on your skin and you still feel hot. But if the air is dry, the sweat can evaporate and cool your skin.
So when it's humid, it's harder to cool your body down?
Right. And you may feel more tired.
Michael, humidity was not a problem for you, right?
Not at all. I lived in a very dry place.
Did you live in the desert?
Yes, for a short time I was living in the desert near Mexico. They only get 2 to 3 inches of rain in a year, so it's very, very dry.
And hot?
Yep, it's one of the hottest places in the world, actually. One day, I remember, it was very hot and dry, and the wind blew up a dust storm.
What was that like?
Well, it was like fog. I couldn't really see anything. I was driving with my friends, and we stopped our car.
Did you get out of your car?
Just for a minute. The wind was blowing the sand all around us, just like in the movies. And it was so hot. We spent maybe 1 minute outside the car, and then we said, "This is crazy. Let's get out of here."
Did living in the desert affect you physically?
It was difficult to get used to the strong heat. I had to drink a lot more than usual to make sure my body got enough water. In fact, I probably drank, a half gallon to a gallon of sports drinks a day.
How is the air quality?
Most of the time the air was very clean, but it did dry you out. I noticed that my lips and skin were dry all the time.
Was it hard to breathe the air?
Oh yes. When it was really hot and dry, you had to be careful not to exercise too much. It would almost hurt your lungs. You'd want to wait until it cooled down a bit in the evening.
Lecture. Ken Needham. What is in the air out there? Before the lecture. Identifying key vocabulary in the lecture. Page 97. 1.
The amount of water vapor in the air, in other words, the humidity level, is something I know you're all familiar with.
2.
Have you ever thought about the idea of solids in the air? The term particulate matter is defined as any tiny pieces of solids that are small enough to float in the air.
3.
Flowers, trees, plants, they release pollen, or a powder made by flowers, and other natural matter.
4.
Humans also add particulate matter to the air. Because of human actions, there are some substances in the air that shouldn't be there. Or there's too much of certain substances, and this is what we know as pollution.
Lecture. Part 1. Humidity. Organizing your notes in an outline. Page 99.
Take a deep breath. Have you ever thought about what you breathe in every time you take a breath? We can't see it, we can't feel it, but air is all around us. Because we can't see air, we often think that air is empty. But air actually contains many different things. So today, I'd like to talk about what's in the air out there. You probably know that air around you is composed of a lot of different gases. The two main gases that make up the air are nitrogen and oxygen. Nitrogen makes up 78%, and oxygen makes up 21% of the air we breathe. But there are also about 10 other gases that are in the air in very small amounts. And even though we can't see or smell or taste these gases, we could not live without them. The amount of water vapor in the air, in other words, the humidity level, is something I know you're all familiar with. If you hear on the news that today's humidity is 80 or 90%, that means there's a lot of water vapor in the air. If you are outdoors and it is hot and humid, your clothes will probably feel sticky and you'll probably feel uncomfortable. But if you hear that today's humidity is 50%, that means there's a lot less water in the air. 50% is comfortable for most people. Deserts and other dry places can have a humidity level of only 10%. Not much water in the air at all. When you're outside in 10% humidity, your mouth will probably feel dry and you'll need to drink something soon. Before we move on, let's talk about how water vapor gets into the air. Now, the most obvious source is rain, snow, and other forms of liquid or solid water that falls from the clouds. Sometimes the rain or snow changes to vapor as it falls, and it stays in the air. But water vapor can also enter the air from sources on Earth, from oceans and rivers, from trees and plants, and even from the ground.
Lecture, Part 2. Particulate matter. Organizing your notes in a chart. Page 101.
So far, we've talked about gases and water vapor in the air. Have you ever thought about the idea of solids in the air? The term particulate matter is defined as any tiny pieces of solids that are small enough to float in the air. Now, these tiny pieces of matter are so small that they're carried in the air and they're too light to fall to the ground. There are many different kinds of particulate matter. Some are found in the air naturally, and others are human-made. That is, they're the result of human activity. I'd like to talk about a couple of different types of particulate matter. Let's start with particulate matter that occurs naturally. When a volcano erupts, it shoots smoke and ash into the air. In the same way, a forest fire fills the air up with smoke. When the ocean waves crash against the shore, salt and sand fly into the air. Flowers, trees, plants, they release pollen, or a powder made by flowers, and other natural matter. Have you ever walked through a field and then started sneezing? That might be pollen in the air entering your nose. Dirt and dust from the environment may be picked up by the wind, then fly into our eyes and make them red and itchy. All of these are examples of naturally occurring particulate matter that is found in the air. Humans also add particulate matter to the air. Because of human actions, there are some substances in the air that shouldn't be there. Or there's too much of certain substances, and this is what we know as pollution. When humans burn wood for cooking and heating, or they burn plants or trees, they add particulate matter to the air. When humans cut down trees and take water from the land, it's easier for dirt and dust to be picked up and carried in the air. But the activity that creates the most pollution is the burning of coal and other fossil fuels. This means every time we use fuel to power a factory or run a car, pollution is added to the air we breathe. When we breathe these particles in, they can hurt our eyes, our throats, and our noses, or cause more serious health problems. Let me just remind you, the next time you look around at all that empty air, there really is a lot out there.
Unit 3. The air around us. Chapter 6. Weather and climate. Getting started. Listening for specific information. Page 104. 1.
It's going to be a beautiful day today. We're looking at a clear sky, no clouds, and warm temperatures. Be sure to get outside and enjoy the weather.
2.
You may want to leave work early this afternoon, everyone. It's already very cloudy out there, and we have some strong wind. The thunderstorm will be here in about an hour. Be careful driving.
3.
It's getting colder and colder. It has been raining all morning, but soon that rain will change to snow. It looks like temperatures are going to get even colder tonight, so be prepared for a lot of snow tomorrow morning.
4.
The good news is the heavy rain has ended. The bad news is we're still going to have a lot of fog today, but it's definitely better than yesterday.
Interview 1. A future meteorologist. Listening for specific information. Page 106.
Sarah, tell me a little bit about yourself.
Okay. I'm from Portugal, and right now I'm a graduate student. I'm studying meteorology.
Could you explain what meteorology is?
Well, meteorology is the study of our planet's atmosphere. It is a way of describing and trying to understand what happens in the atmosphere.
How did you become interested in meteorology?
It's funny. When I was a teenager, I couldn't decide what I wanted to be. My father always told me science is a good subject to study. He said, "Science is very good. Scientists can do many things." I guess he influenced me because I chose science as my major.
So your father influenced your decision to study meteorology.
Yes, and another reason is I've always had a fascination with the sky. When I was young, I would stare at the sky, looking at the clouds and watching them pass.
You like to watch the clouds.
I wanted to know why one cloud is different from another one. And one day, when I was around 17 years old, I told my mother, "Why don't I study meteorology? I like the sky."
Are you happy that you chose meteorology as your major?
Yes, very happy. Our atmosphere is so important. People don't realize. I think because we can't see air, we think the air is nothing. But that's not true.
Of course not. We all need air to survive.
Think of it this way. Earth is like a big aquarium. We are just like fish who live in the aquarium. And our atmosphere is just like water. Fish need water to survive, and we need air. Without the atmosphere, all human beings on Earth would die.
Listening for specific information. Page 106.
Our atmosphere is so important. People don't realize. I think because we can't see air, we think the air is nothing. But that's not true.
Of course not. We all need air to survive.
Think of it this way. Earth is like a big aquarium. We are just like fish who live in the aquarium. And our atmosphere is just like water. Fish need water to survive, and we need air. Without the atmosphere, all human beings on Earth would die.
Interview 2. Severe weather. Predicting the content. Page 107. 1.
Dorothy, tell us about your experience.
Well, I was in a blizzard last October. It really was a freak storm. I mean, generally we don't get much snow in New York in October, but this was a lot of snow.
2.
Yukiya, what kind of severe weather did you experience?
In my case, I was caught in a flood about 2 years ago.
3.
Evelyn, you were also in a dangerous situation.
That's right. When I was 16 years old, a hurricane struck my hometown.
Interview 2. Severe weather. Predicting the content. Page 108.
You've all had experiences with severe weather. Dorothy, tell us about your experience.
Well, I was in a blizzard last October. It really was a freak storm. I mean, generally we don't get much snow in New York in October, but this was a lot of snow.
Did the snow come quickly?
Yes, very quickly. The snow started falling on a Thursday, and it was falling very fast, and by Friday morning we had about 2 feet of it.
2 feet of snow.
The worst part was that it was very heavy, wet snow, and the weight of the snow brought down a lot of tree branches. And then, when the tree branches broke, they fell onto the power lines, and the power lines came down too.
Oh no. That means no electricity.
Right. After the blizzard, so many people were left without electricity. The power was off for 2 weeks, in some places even longer.
How about you? Did you lose power in your home?
Yes, but we were lucky. Our power came back on after 4 days.
Yukiya, what kind of severe weather did you experience?
In my case, I was caught in a flood about 2 years ago.
A flood? So, you were caught in a lot of water.
A lot of water, caused by a lot of rain.
What do you remember about it?
I remember I was at school, studying, and at that time I was stressed out about my homework, and it was raining really hard, but I didn't pay much attention to it. Then, all of a sudden, the lights went out.
You lost power?
Yeah, no power. So I went outside, and when I opened the door, I saw all this water pouring into the parking lot.
Coming toward you?
Well, it was flooding into the parking lot. It looked like a big pool. But I had to get out of there, so I had to go through the water. First, it came up to my knees, and then it came up to my waist. I actually saw one car floating.
Was it still raining?
It was raining really hard, and all around me there was water and mud and tree branches and all kinds of broken things. It was crazy.
Were you scared?
Yes, I was scared, but at the same time, I was kind of excited. I'd never seen anything like that before. I was like, this is definitely going to be on the news.
Did you get out of the flood safely?
Yes, I finally got out and I went home. I was fine, just, I was soaking wet.
Evelyn, you were also in a dangerous situation.
That's right. When I was 16 years old, a hurricane struck my hometown.
And this was a very powerful hurricane?
It was a Category 4 hurricane, so one of the strongest hurricanes to ever hit the United States.
Do you remember what it was like when the hurricane hit your hometown?
I remember when the hurricane hit, it was amazing. Houses right across the street from me were torn apart. Trees were pulled out of the ground and thrown down the street.
Wow. The wind was pulling the trees out of the ground?
Yeah, trees and lampposts were flying everywhere.
Scary.
Yes, it was scary. But I also thought it was kind of fun. I guess that sounds strange, but I was pretty young at the time, so it was exciting. Of course, I was worried about the families in the houses that were destroyed.
Was your house damaged?
No, my house wasn't damaged badly. We were lucky. But after the hurricane, the whole town didn't have power for a couple of months.
What a terrible experience.
But I learned a lot from that experience. Now I know if there's ever a warning about a natural disaster, I need to take it seriously. Once you experience something like that, you remember it for the rest of your life.
Listening for opinions. Page 108.
I'd like to ask you about global warming. Sarah, you're a meteorology student. Do you think global warming is affecting our weather on Earth?
Well, my opinion is global warming is really happening, and everybody knows that. And everybody knows that human beings are a little bit responsible for it. But as for the weather, there are some changes that I think are natural. Changes that would probably happen even without people.
So, in your opinion, global warming is not affecting our weather?
I don't know. With science, until you have the right answer, you can't say for sure. I can't say for sure if global warming is affecting our weather or not.
Dorothy, do you think global warming is affecting our weather?
Personally, I do. Just look at the weather these days. Hurricanes are becoming stronger and more severe. I don't think it's just the natural cycle of things.
And do you think the cause is global warming?
Yes, I can see how the weather has changed just in my hometown. The winters used to be longer and colder, and now they're warmer and there isn't as much snow.
Yukiya?
I agree with Dorothy. I'm not a scientist or anything, but I've heard that global warming is melting the ice in Antarctica. And the water level of our oceans is going up, and that's what causes the hurricanes. I'm sure global warming is having some effect on the weather.
Evelyn?
I agree. I think global warming is making the weather worse, and there's more risk of dangerous weather. Because humans are changing Earth, that's causing the weather to change. We need to start doing some things soon to protect our environment, or it's all going to be gone.
Lecture. Fred Mackenzie. Global Warming. Before the lecture. Listening for numerical information. Page 112. 1.
Since the beginning of Earth, about 4.6 billion years ago, there's been a mixture of gases surrounding the planet.
2.
The atmosphere acts as a kind of a shield and a filter. It reflects about 30% of the sun's energy back into space. About 70% of it actually passes through the atmosphere. Of that 70%, much of it is absorbed by the clouds and air. Only half of the energy that passes through the atmosphere, about 35%, reaches the Earth's surface, which is warmed by the sun's energy.
3.
This has led to a heating of Earth's surface. In the past 100 years, scientists have found an increase of 1 degree centigrade in the average temperature on Earth.
4.
But unless we change the way we do things today, which means we must stop relying on fossil fuels for 80% of our energy supply, the amount of greenhouse gases will continue to increase and temperatures will continue to go up.
Lecture. Part 1. The Greenhouse Effect. Copying a lecturer's illustrations. Page 113.
Well, the topic of my lecture today is global warming. But before I talk about that, I'm going to give you some background information about Earth's atmosphere. As you already know, the atmosphere is what we call the layer of gases that surrounds the planet. Since the beginning of Earth, about 4.6 billion years ago, there's been a mixture of gases surrounding the planet. Now, some of these gases are called greenhouse gases. We call them greenhouse gases because they create a greenhouse effect. That is, they make the atmosphere warmer because they absorb heat from the sun. Well, let's look more closely at the interactions that lead to the greenhouse effect. Energy from the sun is the force behind our climate systems. It approaches Earth and enters the outer layers of our atmosphere. Now, the atmosphere acts as a kind of a shield and a filter. It reflects about 30% of the sun's energy back into space. About 70% of it actually passes through the atmosphere. Of that 70%, much of it is absorbed by the clouds and air. Only half of the energy that passes through the atmosphere, about 35%, reaches the Earth's surface, which is warmed by the sun's energy. The Earth emits or sends this energy back towards the atmosphere. About 10% of it leaks back into space, but most of the heat stays inside our atmosphere. This process helps to maintain global temperatures within certain limits. It's called a greenhouse effect because warmth is sealed inside, just like in a greenhouse. We've always had greenhouse gases in our atmosphere, and we've always had a natural greenhouse effect on this planet. But what has happened in the past century or so is that human activities have added more greenhouse gases to the atmosphere. As a result, the greenhouse effect has become stronger. With more greenhouse gases in the atmosphere, more energy from Earth is absorbed. This has led to a heating of Earth's surface. In the past 100 years, scientists have found an increase of 1 degree centigrade in the average temperature on Earth. While there has been some debate, I think people have realized that the increased greenhouse effect is causing the problem of global warming.
Lecture, Part 2. Effects of Global Warming. Listening for Cause and Effect. Page 115.
An increase of 1 degree centigrade in Earth's temperature may not seem like a lot, but it actually causes many changes on our planet. What are the consequences of this increase in Earth's temperature? Today, I'd like to focus on 2 effects of global warming. The first is an increase in sea level. The sea level has risen over the past 100 years between about 15 and 25 centimeters. It is rising now and will continue to rise in the future. Some of this rise is due to the heating of the ocean surface. When ocean waters warm, they expand or get bigger, and so the sea level rises. Another cause is melting ice and snow. The meltwater is entering the ocean and resulting in a rise in sea level. Changes in the weather are another consequence of global warming. As Earth's temperatures continue to rise, some areas of the world will become wetter and some will become drier. Already, many countries around the world are experiencing more and longer periods of drought. In other words, long periods of time without enough rain. In fact, the amount of land affected by drought has doubled since the 1970s. Another example of weather change is an increase in severe storm activity. Some scientists believe that if global warming continues, we will have more hurricanes. Hurricanes develop over warm oceans, and so the rise in ocean temperatures may cause more and perhaps stronger hurricanes. Today I told you about just 2 effects of global warming: a rise in sea level and changes in the weather. There are many other consequences of global warming. It's difficult to predict the future. But unless we change the way we do things today, which means we must stop relying on fossil fuels for 80% of our energy supply, the amount of greenhouse gases will continue to increase and temperatures will continue to go up. Scientists predict that this century, temperatures will rise to about 3 degrees centigrade higher than they are now. Sea levels are also likely to go higher, about 60 centimeters above their current level. So, global warming is a real problem for all of us. It may be the most serious problem in our world today. And I think all of us, as individuals, must take action to solve this problem.
Unit 4. Life on Earth. Chapter 7. Plants and Animals. Getting Started. Listening for Specific Information. Page 127. 1.
The blue whale is the largest animal in the world. Many scientists think that the blue whale is the largest animal that has ever existed on Earth. It can grow up to 33 meters long and weigh as much as 150 tons. Its heart is the same size as a small car. The blue whale's natural habitat is the deepest waters of all the world's oceans.
2.
The Venus flytrap is a very unusual plant because it is a plant that eats meat. The Venus flytrap catches insects in its leaves and then eats them. This plant's natural habitat is in the United States, but now it grows all over the world.
3.
The platypus is a very unusual animal. It has a bill and webbed feet like a duck, but it has a wide, flat tail. It lives on land, but is a very good swimmer. The platypus lives only in Australia.
4.
Trees are the biggest plants in the world. The largest type of tree on Earth is the giant sequoia. The natural habitat of the giant sequoia is the mountains of California. These trees can grow to be more than 100 meters tall.
5.
Almost half of all insects on Earth are beetles. Scientists have already found 350,000 different kinds of beetles. They can live everywhere, except for the ocean and cold polar regions. The beetle, pictured here, is the Goliath beetle, the largest and heaviest insect on Earth.
6.
Many people think that bamboo is a kind of tree, but actually, bamboo is a type of grass. Bamboo is the fastest growing plant on Earth. It can grow 4 centimeters in just 1 hour. Bamboo can be found in many different habitats, from cold mountains to hot tropical jungles.
Interview 1. A green thumb. Listening for specific information. Page 129.
Frank, your hobby is gardening, right? How did you get started?
Well, let me take you back a long, long time. When I was a kid, everybody had gardens. Wherever we could find a little space, we'd plant some vegetables, like tomatoes or something like that.
Did you grow vegetables because you could eat them?
We didn't have a lot of money back then, so yes, we planted and grew things we could eat. And so because I grew up in that situation, I was always interested in planting and growing things. These days, I enjoy growing native plants.
What does that mean, native plants?
Native plants are plants that are originally from the area in which they are found. So I like to look for and collect plants that grow in my neighborhood.
What got you interested in native plants?
Well, one of the reasons is to collect native plants, I have to go to places where other people don't go. I don't like to go where lots of other people have already been. I like to get off the trail.
So you like the challenge of finding and collecting the plants?
Yes, and there's something else I like too. I like to share with other people who are also interested in native plants.
Vicky, how about you? What attracted you to gardening?
Well, when I was young, everyone was trying to be more green and natural and grow their own food. I tried it too and found out I was good at growing plants. I just kind of had a knack for it.
What sort of plants were you growing?
When I started, I only had a small apartment, so I was growing houseplants. I also had a few tomato plants and some herbs.
Okay.
And then, when I bought a house, I started to do more gardening outside. Now what I do is mostly perennials. That's really my love now, the perennials.
Can you explain what a perennial is?
Well, basically there are 2 kinds of plants, annuals and perennials. Perennials are plants that come back year after year.
Oh, that makes sense, because perennial means for a long time.
Annuals are the ones that die in the winter, and they don't come back. Perennials look like they die in the fall, but they've really just become inactive. They come back up again in the spring, and that's what I find so exciting. Most perennials go through that cycle for years and years. Some plants even live longer than humans. You plant them, and your grandchildren will have the same plants. I really like that.
You said that you have a knack for growing plants. Why is that? What makes your plants grow better?
You know the expression having a green thumb? I guess that's what I have. But I think it's just an ability to notice little differences.
Differences in the plants?
The plants and their environment. You see a plant that's doing well in an environment, so you try to continue the same kind of care. If you have a plant that's not doing well, you have to find out, is there too much sun? Is there not enough sun? Is there enough water? Is there too much water?
I see. Vicky, is it true that gardening makes people feel calm and relaxed?
Well, it's true for me. I go out to my garden and I get right down, put my hands into the dirt, smell the plants, and I can forget about my day-to-day troubles. When I'm in the garden, I don't think about my worries and responsibilities. I feel very connected to the earth, very relaxed and focused. And so for me, it's very calming.
Interview 2. The Galapagos Islands. Listening for examples. Page 131.
Reggie, you went to the Galapagos Islands. Why did you go and how long did you stay?
Well, I was there for about 5 weeks. I decided to volunteer there because I'd heard so much about it. You know, we all dream about going to the Galapagos.
What is it about the Galapagos Islands that's so special?
The number one reason why people really want to go to the Galapagos is the diversity of the wildlife. There are so many different and unique animals there. It really is special.
And did you get to see some of the diverse wildlife?
Absolutely. You don't have to go far before you see wildlife. For example, on the day I arrived, I was traveling from the airport and I saw Galapagos sea lions right away. I'd been there only 20 minutes and I saw sea lions. They were sleeping on benches meant for people.
Can you give me some other examples of animals you saw there?
Well, I saw a lot of birds, many different kinds of birds, like blue-footed boobies, red-footed boobies, albatross, also pelicans, flamingos, and penguins. Those are some of the birds I remember.
That sounds amazing.
Yeah, but here's what surprised me. There's been a lot of environmental damage already, so the idea that it's an untouched environment is wrong. Let me give you an example. There used to be 13 subspecies of Galapagos giant tortoises, but now 2 are extinct, and a third subspecies of tortoise is almost extinct.
Okay, some people might ask, is there really a problem if a few subspecies of tortoises disappear? We still have 10 others. What would you say to those people?
Well, I'd say that it shows a lack of understanding. Because any ecosystem is so closely connected that even one small thing can change the balance and destroy the system. For instance, there's a tree that one kind of bird uses for food and shelter. If you cut down the tree, you lose the bird too.
So losing even one plant or one animal can have a bad effect.
That's right. And if we lose a living thing, we can't get it back. Once it's gone, it's gone.
Lecture. John Norris. What is a living thing? Before the lecture. Listening for expressions of contrast. Page 136. 1.
Plants, for example, grow taller and wider throughout their lives. Animals start growing as soon as they're born. Unlike plants, however, they usually stop growing when they become adults.
2.
I'm sure you can think of many examples of different kinds of animal movement. Walking, flying, swimming. Plants move too, but not in the same way as animals.
3.
Plants have a very special way of getting food. They make it themselves. To make their own food, plants take a gas called carbon dioxide out of the air. They combine the carbon dioxide with water and sunlight to make food. This food is stored inside the plant and used when the plant needs energy. Animals, on the other hand, cannot make their own food.
4.
The process of respiration helps to change the food into energy. Now, animals take in oxygen by breathing in the air, whereas plants take in oxygen through tiny holes in their leaves.
5.
During reproduction, plants and animals make more of their own kind. Animals have babies or lay eggs. In contrast, most plants make seeds which fall onto the soil and grow into new plants.
Lecture. Part 1. Growth, Movement, and Sensitivity. Checking your notes. Page 139.
Welcome to today's biology lecture, everyone. Biology is the study of all living things on our planet. But what do we mean when we say living thing? What does it mean to be alive? Well, scientists have a very clear way to answer that question. When scientists want to check if something is living or non-living, they look for 7 life processes, or 7 special actions that all living things must do. The 7 life processes are movement, reproduction, sensitivity, growth, nutrition, respiration, and excretion. These 7 actions are like a checklist. If something has all 7, it's a living thing. But even if one process is missing, then it cannot be called a living thing. As you can see, this checklist is very important to biologists. So in our lecture today, let's look at each life process in more detail. I'll start with 2 life processes that are easy to observe and understand. Growth and movement. All living things grow, which means they increase in size. Plants, for example, grow taller and wider throughout their lives. Animals start growing as soon as they're born. Unlike plants, however, they usually stop growing when they become adults. All living things also move. I'm sure you can think of many examples of different kinds of animal movement. Walking, flying, swimming. Plants move too, but not in the same way as animals. Plants move their roots down into the earth and their leaves up towards the sky. Some flowers open in the morning and close at night. Of course, the movement of a plant is much slower than the movement of an animal. An interesting similarity between plants and animals is that they all move for the same reasons: to get food, to find a safe place to live, and to escape from danger. Let's move on to the 3rd life process on our checklist. This next process is called sensitivity. What that means is that living things notice their environment and respond to changes in their environment. Animals take in information about their environment by using their senses. In other words, they see, hear, smell, taste, and feel things around them. Plants also take in information about their environment. Although plants do not have as many senses as animals, they do notice changes in water and light. The sunflower got its name because it turns its flower to follow the sun all day long.
Lecture. Part 2. Nutrition, Respiration, Excretion, and Reproduction. Organizing your notes in a chart. Page 140.
The next 2 processes are nutrition and respiration. You've probably heard of nutrition before. That's the process of getting food, and all living things need food for energy. Plants have a very special way of getting food. They make it themselves. To make their own food, plants take a gas called carbon dioxide out of the air. They combine the carbon dioxide with water and sunlight to make food. This food is stored inside the plant and used when the plant needs energy. Animals, on the other hand, cannot make their own food. Because of this, they have to eat plants or eat other animals that have eaten plants. Okay, so once food is inside a plant or animal, the next life process begins, respiration. And what is respiration? The process of respiration helps to change the food into energy. Now, animals take in oxygen by breathing in the air, whereas plants take in oxygen through tiny holes in their leaves. In other words, we see that both plants and animals need and use oxygen to change food into energy inside their bodies. All living things need energy to support all the other life processes. So, you can see why nutrition and respiration are so important. During respiration and the other life actions, plants and animals create waste materials. These are extra materials that a living thing doesn't need or want. If the waste isn't removed, it will become harmful. Plants pass waste through their leaves and through their roots. Animals move waste out of their bodies in their breath, sweat, urine, and excrement. To quickly review then, all living things grow, move, react, eat, respire, and excrete. All living things also grow old and finally die. So the final life process, reproduction, is necessary for life to continue into the future. During reproduction, plants and animals make more of their own kind. Animals have babies or lay eggs. In contrast, most plants make seeds which fall onto the soil and grow into new plants. All right, that's our checklist. For something to be called living, it must show all 7 life processes: movement, growth, sensitivity, nutrition, respiration, excretion, and reproduction. Usually, we can easily identify something as living, but remember, it must meet all 7 life processes. An automobile moves, an automobile can be sensitive, an automobile requires nutrition, like gas, and it excretes smoke. But is it alive?
Unit 4, Life on Earth. Chapter 8, Humans. Getting started. Listening to directions. Page 143. Task 1.
Look at the picture in your book. Put the palm of your right hand down on top of a desk or table. Keep your arm relaxed. Put your left hand on the upper part of your right arm. Now, press gently down on the table with your right palm. Use your left hand to feel the muscles in your upper arm. Now, place your right palm under the desk or table. Push your hand gently up against the table. Use your left hand to feel the muscles in your upper arm. Now, answer the question in your book.
Task 2.
Place your hands on your sides, just above your waist, so that you can feel your ribs. Notice how your ribs move out when you breathe in, then fall back down when you breathe out. When you hear the beep, count the number of breaths you take in 10 seconds. 1 in plus 1 out equals 1 breath. Try to breathe naturally, without changing or controlling your breathing rate. Are you ready? Okay, start. Stop. Write the number of breaths you took in your book. Multiply that number by 6. This is your average breathing rate per minute.
Task 3.
Find the pulse on the inside of your wrist. Place your first 2 fingers on your pulse point, as shown in the picture. Try to relax and let your fingers rest lightly on your wrist. When you hear the beep, count the number of beats you feel in 10 seconds. Are you ready? Okay, start. Stop. Write the number of beats you counted in your book. Multiply that number by 6. This is your average heartbeat rate.
Interview 1. Running track. Listening for main ideas. Page 147.
Becca, you were an athlete when you were a student, is that right?
Yes, I was on the track and field team in college.
What kinds of training did you do?
The training, well, the coaches really break it down into steps. So the first step was a lot of weightlifting, like good, strong weightlifting. Then the next step was cardiovascular training.
Did you say cardiovascular training? What does that mean exactly? Training to help you breathe better?
Breathe better, yes, but also to make your heart stronger and to make your whole cardiovascular system work more efficiently.
And what kinds of exercises did you do for cardiovascular training?
Well, first, we would get a good warm-up, with a 3 to 5 mile run. After that, we did drills. With drills, you practice running form. That is, the best positions for your body when running. You practice the drills over and over again until your body remembers the positions.
Long runs, drills, anything else?
Next came the track workouts.
And that's running around a track?
Yes, these are shorter distances, but faster and with breaks in between. The coach would have us run really hard for a minute, then take a break for 5 minutes until we were fully rested, and then go right back into sprinting for another minute.
Can you explain how all of these different exercises helped your body?
Well, the long-distance running, that's really good for cardiovascular training because you're running at a slower pace but for a long time, so you build up your lungs and heart. And sprinting, the fast, short running, is good for strengthening your muscles.
So really, the muscles and the cardiovascular system are closely related.
Very closely, especially because when you're running, your muscles need oxygen so that they can work. When you run, you start breathing faster and harder, right? That's because your muscles need more oxygen. So you breathe in more air, and the oxygen goes into your lungs, your blood, and your muscles. So the cardiovascular system and the muscular system are very closely connected.
It sounds like running is a really good sport to make your body stronger and healthier.
Definitely.
Interview 2. Eat to live. Don't live to eat. Listening for specific information. Page 149.
Louise, you're a registered dietitian. Why is good nutrition so important?
You need to eat to live, basically.
It's the basic idea, but people don't think about that.
Because I think more people, instead of eating to live, they live to eat. In our society, so many activities are centered around food. You have a special event and you go out for dinner. It's a holiday, so you buy some candy. A lot of our social events are centered around food, and I think that's part of the problem.
What's a healthier way to think about food? How can people remember that we need to eat to live?
Just think of what your body really needs. There are some basic food groups that people should eat every day, such as grains, vegetables, fruits, and certain kinds of fats.
We should eat fat every day?
Good fats. Also, fiber and vitamins and minerals. Those 6 nutrients are your body's basic needs.
So as long as we eat all of those things every day, we'll have a healthy diet?
Right. And, of course, you have to be careful of how much you eat. You don't want to eat too much of any one thing.
Can you explain how these different food groups help the human body?
Yes, absolutely. Let's start with fiber. I talk to my patients about fiber because fiber can help lower your cholesterol. If you have fiber in your diet and you also have some cholesterol in your body, the fiber can actually pull the cholesterol out of your blood.
So, that's good?
Yes, it's good. I should point out that cholesterol is a natural part of our cells. You can't get rid of cholesterol. But there's good cholesterol, which isn't a problem, and bad cholesterol. Bad cholesterol is what clogs our blood vessels.
Now, how about protein?
Yes, you need protein. Protein has a lot of different functions, but mostly you need protein for your body to grow and to build muscles. That's the main role, to build and repair our muscles.
Protein for strong muscles. Got it. And carbohydrates and fats?
Those are your energy sources. We need a lot of energy every day, so that's why carbs are so important. And I know people think fats are bad, but you need fats to help protect your organs and to provide energy too.
Are there foods you can eat to build strong bones?
For bones, you should look at calcium and vitamin D. Those go hand in hand. You always hear about calcium because that's basically what makes your bones. But you need vitamin D to absorb the calcium from food.
It sounds like you can't eat only one kind of food. You need to have a mix of many different kinds of food.
Exactly. And to be healthy, you have to have good eating habits and also exercise. I cannot stress that enough.
Louise, I feel like there is so much need for this type of information right now. I'm just thinking of all of the problems that Americans are having with diet and nutrition.
I really enjoy helping people with the little things that can help them in their everyday life. Eat breakfast, drink water, cut back on coffee. Small, easy steps that people can see making a difference. That's empowering.
Lecture. Anthony Modesto. Systems of the Human Body. Before the lecture. Listening for expressions of time order. Page 153. 1.
This phase can last for several hours, and when it's over, the food has become a thick soup.
2.
From the stomach, it then moves into the small intestine where something very important happens.
3.
After taking all of the nutrients out of the food, the body doesn't need the leftover food anymore.
4.
When we breathe, air enters our body through our mouth and nose. Next, it travels through an airway into our lungs.
5.
Finally, the blood returns to the heart, ready to begin the cycle all over again.
Lecture. Part 1. The Digestive System. Taking notes in a flowchart. Page 155.
Have you ever thought about all the things that happen inside your body? The human body, like all living organisms, has many different systems, which is the topic of our lecture today. A body system is defined as a group of organs that work together to carry out a very specific function. Humans have 11 different body systems. These systems carry out every function necessary for life. When your body is healthy, the systems work together very smoothly. But if even one of the systems breaks down, you'd be in big trouble. You wouldn't be able to survive. Today, I'd like to focus on 3 of the 11 human body systems: the digestive system, the cardiovascular system, and the respiratory system. These 3 systems each have their own role in the body, but they also work together in very important ways. Together, they bring oxygen and nutrients to every part of the body. Of course, humans need oxygen and nutrients to live, so our digestive, cardiovascular, and respiratory systems are really important. Okay, where should I start? We all like to eat, so maybe I'll start with the digestive system. Our bodies use the energy in the food we eat to carry out all of our daily life functions. To get the energy from food, our body has to break it down and take the nutrients out of it. This process is called digestion. Digestion begins as soon as you put food into your mouth. As your mouth moves and chews the food, it becomes softer and breaks apart into smaller pieces. When the pieces of food are small and soft enough to swallow, they travel from your mouth down to your stomach. There in the stomach, powerful muscles squeeze the food and mix it together with chemicals. This phase can last for several hours, and when it's over, the food has become a thick soup. From the stomach, it then moves into the small intestine where something very important happens. Nutrients from the food pass through the intestine and move into the blood. Those nutrients have now become part of the cardiovascular system, which I'll talk about next. We're not quite done with digestion. There's one more step. After taking all of the nutrients out of the food, the body doesn't need the leftover food anymore. This waste moves into the large intestine and finally out of the body. The whole process of digestion from mouth to large intestine takes about 24 hours to complete.
Lecture, Part 2, The Respiratory and Cardiovascular Systems. Taking notes in a flowchart. Page 157.
Another important system is the respiratory system. Now, the job of this system is to bring oxygen from the air into the body. When we breathe, air enters our body through our mouth and nose. Next, it travels through an airway into our lungs. The air that enters our lungs is rich with oxygen. Inside the lungs, all of this oxygen passes into our blood. Like food, oxygen is necessary for life. Our body uses oxygen to carry out all of its life functions. We need to breathe about 8 liters of air every minute to stay alive, and even more when we exercise. Without oxygen, we would die in just a few minutes. By now, you've probably figured out that blood has many important roles in the human body. It brings nutrients from food and oxygen from the air to every part of our body. Blood is part of the cardiovascular system, and that's what I want to talk about next. The cardiovascular system is made up of 3 things: our blood vessels, and the heart. The heart is the source of power in the cardiovascular system. With every beat, the heart pushes blood in a cycle around the body, from the heart to the body, around the body, and finally, back to the heart again. When blood first leaves the heart, it's oxygenated, which just means that it's carrying a lot of oxygen. Vessels carry this oxygenated blood all over the body. One of the places the blood goes to is our small intestine. And do you remember what I said? What happens in the small intestine? That's where the blood picks up nutrients from food. As blood travels around the body, it gives oxygen and nutrients to each cell. When the oxygen in our blood has been used up, blood vessels carry it back to the heart. Then it's pumped into the lungs to get fresh oxygen from the respiratory system. Finally, the blood returns to the heart, ready to begin the cycle all over again. The entire cycle from heart to body and back to heart to lungs and back to heart again takes only 20 seconds. Well, that's a pretty simple overview, but I hope you can see how these 3 systems, digestive, respiratory, and cardiovascular, work together to maintain life. The digestive system brings nutrients into the body. The respiratory system brings oxygen into the body. The cardiovascular system carries nutrients and oxygen to the cells. Today we talked about only 3 of the body's 11 systems. When you consider that there are 8 other equally important systems, you can see that the human body is truly amazing.